Hello and welcome to your fifth online pre-cal class. My name is Mr. Marcus and I will be your summer school math facilitator, teacher, favorite math teacher, whatever you want to call me. Today we're going to talk a little bit about rational expressions or evaluating rational expressions, and using rational properties. Now, square roots are not common because we've seen this a lot in like 7th and 8th grade algebra. And basically a square root, or at least the perfect square root, is it's like saying what two even numbers equals a given radical expression. So for example, the square root of 4 is 2 because 2 times 2 is 4, right? And we're going to see that. But there are more than just square roots. We have cube roots, fourth roots, fifth roots, and we call them n roots. So let's look at this real quick. So the first one says the square root of 36. Well, obviously the square root of 36 is 6 because 6 times 6 is 36. Now we have a negative sign. Now a negative sign can be outside of a radical, especially if it's a square root and an even exponent, and we're going to talk about that a little bit later on. We can just say, well, 6 times 6 is 36, but because there's a negative sign on the outside, we simply say negative 6. Had the negative sign been inside of the radical expression, and the exponent was an even, like square root or fourth root or so on and so forth, we say that doesn't have a real answer. And I'm going to explain that in a minute, but for the time being, 6 times 6 is 36, and I just moved the negative sign. Now, I see my first n root. Specifically, I have the cube root of 125 over 64. Now, one of the things you can do is first separate the fraction, and we can say the cube root of 125 over the cube root of 64. Now, just like in a square root, comparing in terms of comparison, just like the square root of 36 is 6 because 6 times 6 equals 36. When you're looking for a cube root, you're looking for, in this case, what three numbers multiplied by itself gives me a given result. In this case, what three numbers multiplied by itself equals 125. And in that case, it will be 5 because 5 times 5 times 5 equals 125. Now, if I want to do the same thing with 64, it's the same. What three numbers multiplied by themselves 3 times equals 64? In this case, it's 4 because 4 times 4 times 4 equals 64. So we simply say that the cube root of 125 over 64 equals 5 over 4. Now, if we have the fifth root of negative 32. Now I want to explain something. Sometimes you have odd exponents outside of the radical sign, and sometimes you'll have even exponents outside of the radical sign. Now, they're the same number, but this one has an answer and this one does not have a real answer, and this is the reason why. Never will you be able to multiply a negative number by itself and get a negative answer. For example, negative 2 times negative 2 will always equal positive 4. And 4 times, or if I say an even number like negative 6 times negative 6 times negative 6 times negative 6, this will be a positive answer regardless. And the reason is because this power has an even exponent. So for example, 2 times 2 will always be positive 4 because I can never multiply two negative numbers and get a negative answer. And 6 to the power of 4 will be positive because I can never multiply 6 by itself or any number by itself an even amount of times and get a negative answer. So, but if we talk about odd numbers or odd exponents like 3, 5, 7, 9, they do have an answer because it works the following way. Now, what number multiplied by itself 5 times equals 32? And it would be 2. But if I say negative 2 times negative 2 times negative 2, let me write this down here. So basically, 5, the fifth root of negative 32 is going to be negative 2, and that's because if I say negative 2 times negative 2 times negative 2 times negative 2 times negative 2. If I multiply negative 2 by itself 5 times, I'm going to get a negative number. Let me explain. Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16, and positive 16 times negative 2 is negative 2. So, summarizing this property, if you have if you're trying to find the end root of an odd number and the number inside of the radical is negative, it has it has a real answer, such as the fifth root of negative 32 is negative 2. But if I have the same number, but this number is even, then it has no real answer. Now let's look at the other properties, and we're going to go more in depth into the properties in our next classes. But the first one, what if I'm multiplying two rational expressions? What if I have the square root of 8 times the square root of 2? Well, what you can do is simply put them together and say 8, the square root of 8 times 2, which equals the square root of 16, which equals 4. So whenever you're multiplying square roots, you can just kind of put the square roots together, find your answer, and then calculate the root if it has a perfect root, a perfect end root. In this case, it was a square root, but it could have been cube root, fourth root, etc. Now, in this case, I have the cube root of 5 elevated to the power of 3. Now, in this case, it's really simple. Since this is an odd exponent and this is an odd exponent, they're the same. They simply cancel out, and we say that our answer is 5. Okay? Very simple, very easy. There is a mathematical explanation, and I'm going to give it to you, although if you just do this, it's fine. So technically, what's occurring here is that the cube root of 5 is actually the same thing as saying 5 elevated to the power of 1/3. So in reality, what I'm doing is I'm multiplying 5 elevated to the power of 1/3 elevated to the power of 3. And if I multiply 3 times 1/3, my answer equals 5. So it's not that it magically happens. Like, I can't magically say that, oh, it magically cancels out. No, there's a mathematical explanation. And it's because the cube root of 5 is the same thing as saying 5 elevated to the power of 1/3. And in our previous video, when we talked about properties of exponent, I know that if I have 1/3 elevated to the power of 1/3 here and elevated to the power of 3 here, I multiply them. And 3 times 1/3 is 5. It's just that we don't do all that step, and we simply say that the answer is 5. Same thing happens here. And let me write this down. So let me write it down here so it doesn't look all scrunched up together. Now, if I look at C, it says the cube root of x cubed, and D, excuse me, this is C, and D says the sixth root of y elevated to the power of 6. Okay, so since they're both odd numbers, it's basically the same thing that happened in B happens in C. They're odd numbers, they cancel out, and my answer is simply x. Now, in the case of y to the power of 6, it's the same thing. This 6 and this 6 is going to cancel out, but because they're even, the rule or the property states that you leave it expressed as the absolute value of y, although we do know that the absolute value of y equals y. So whether you leave your answer expressed as the absolute value of y or y, essentially you're going to get the same answer. So this has been your favorite math teacher with today's lesson. Along with this lesson, I'm going to upload some practice problems for you to do, and I'm also going to upload these rules. So check your LMS on College One and check the work that I left assigned for you, and I'll see you soon, so stay safe. Bye.